What family of functions does each graph come from? So you're looking at 5 graphs. And all you need to do is recognize, let's start from the bottom and work up. This comes from the linear family. So just a straight line, the slope, so it's changing, but it's changing at a steady constant pace. So linear family looks, the parent function of all the linears is just y equals x. Okay, this parabola is quadratic family, and the parent function of all quadratics is y equals x squared. So it's changing, but it's getting steeper and steeper, so it's growing faster and faster. Okay, this is absolute value. So it's kind of, you got two linear sections, but it never really dips down below the negative. As soon as it hits the vertex, it turns around and it's reflexive, kind of like quadratic. Absolute value, the parent of all absolute values, is just y equals absolute value of x. Okay, this red one is growing, and it's growing, this grows the fastest. This really starts to take off and grow way, way fast. This is an exponential, and its graph could look like y equals something to the x. So the base, if the base is 2, that means it's growing by doubling every time. Whatever the base is, if the base is 3, that means it's tripling every time. So this is kind of how fast it grows. Okay, this is one that we just introduced. So exponential, the further you go to the left, this goes all the way to negative infinity. This keeps going forever. They all do. This is the one that does not. This is a radical graph, and its parent function is y equals radical x. Okay, the reason it stops right here and there is nothing to the left, because if I go left of 0, if I go y equals radical negative 1, that is imaginary. So anything to the left of that vertex is square roots of negatives, and those are imaginary. Okay, so let's graph a couple of these radical. Now, so you got two functions. Let's sketch a graph of these functions, but first let's do the original, y equals radical x. So y equals radical x, it starts as 0, 0, and it grows, but it's going to grow. I'm not really too worried about the slope. The only point I'm really worried about is this, where it starts. So let's do it on both of them. Y equals radical x. So it's going to start at 0, 0, and it's going to grow, but it's going to kind of grow slow because the bigger number you punch in, so if you punch in 81, if you take radical 81, that's 9. So you're going to go over 81, up 9. So it kind of grows at a slower rate. But, okay, this is the transformation. So remember your a, h, and k. So if you've got y equals a, radical the x minus the h plus the k. So the a, if you're timesing it, that's the slope. If you add or subtract in the parentheses or under the radical, that moves it left and right. And if you add or subtract outside of the radical, that moves it up and down. So, okay, on this first one, my a, I'm timesing it really by just a 1. So my a is 1. My h, the h is what is ever after the subtract. There has to be a subtract, and there's not really a subtract. So it's x subtract a negative 3. My h is a negative 3. H is kind of always what's opposite in the parentheses. K, your k is a minus 2. So my h and k are going to move this starting point. So I start at 0, 0. My h says go left 3. 1, 2, 3. My k says go down 2, 1, 2. So it is going to start right there. And then my slope is going to be the same. So your graph is going to look something like this. The original one in blue is where it started, and this one in red is a transformation, so you slide it over and down. Okay, the second one, your A has a slope, it's going to be a -2. H is what's after the minus, so there's the minus, my H is +4, and the K is +3. So you're going to start at 0, 0, you're going to go right 4, you're going to go up 3, and there is your starting point. Okay, now your slope is a negative. Negative is going to reflect it. It's going to flip it upside down. So instead of going like, and it's 2, so it's going to be a little bit steeper than the original. But the negative is going to flip it upside down. So it's going to look like this. It should look like this bottom one. Something like the bottom one. The top one would be a positive slope. So, there we go. Now, anything, so you kind of have a boundary line right here. Anything over here is all imaginary. It's impossible, because if you're taking a square root of something left of that dot, it is imaginary. Okay, now solving radical equations. These are pretty easy. So you've got to solve for k. You got to get k by itself. You got to undo the 6, undo the radical, undo this first, undo whatever's outside first. So let's undo this 3. -3 minus 3. So I got square root of k divided by 6 equals 1. Okay, now to undo a radical, the inverse of a square root is a square. So I'm going to square this side, I'm going to square this side. The square kills the square root. So I just got k divided by 6 equals 1 times 1 is 1. I'll do the divide 6 times 6 times 6. K equals 6. The second one, you got a radical on the left and you got a radical on the right. So let's lift them off. Square the left and square the right. And if you square both sides, the squares will undo the square roots, so you just got 2x plus 1 equals 3x minus 2. Okay, now I'm going to take my x's over here to the side where there's the most, so minus 2x minus 2x. And I'm going to take these over here, so I'm going to plus 2 plus 2. So on the left I've got 3, and on the right I've got x, and that is your answer. X is 3. Okay, now these, if you've got 10 is your index, so it's the 10th root. It's not a square root, it's the 10th root of 8 to the 5th. Okay, now just kind of morph them back and forth, morph them back and forth. If I morph this, that is, make it look like an exponential form. 8 is my base, and it's 8 to the 5/10. And 5/10 is the same thing. 5 and 10 reduce, they simplify, that's 1/2. So really, they're asking you to do 8 to the 1/2, or if you morph it back to a radical, they're asking you to do the square root of 8. So 8, break it down. 8 is 2 times 2 times 2, and if you're doing the square root of 8, the index is 2. Items come out if they're grouped up in a pair of 2 or more. So this pair of 2's exit, and this stays underneath. So that is your answer in radical form. And if you need an answer in, no, that's your answer, yeah, radical form. If you need it in exponential form, that is invisible 2, that's invisible 1, so you got 2 times 2 to the 1/2. That's what it looks like in exponential form. Okay, the middle one, 8 to the 5/3. 5/3 will not simplify. So if you morph it to a radical version, 8 goes there, it's a cube root, and the 5 goes there. So things will exit if you've got 3 or more. So here we go. 8 is actually 2 times 2 times 2. So I'm going to trade the 8. The 8 is 2 cubed. That is my 8. But I don't have 1 8, I've got 5 of them. So I got 5 of these 2 cubed. So if I've got 2 exponents, you times them. So really, that is the cube root of 2 to the 15th. Okay, now, 4 items to exit, they need to be leaving in groups of 3. So the question is, how many groups of 3 are in 15? And the answer is 5 groups leave. So 2 to the 5th is your answer. And you can change that to a number. 2 to the 5th is 2 times 2 times 2. 8 times 2 times 2. So it's like 32 is 2 to the 5th. The last one, 1024 to the 1/5. Morph it to a radical version. 1024. The index is 5. Okay, 1024. Break it up. 1024 divided by, if you divide it by 2, it might take a while. So I'm trying to find something bigger than 2. Okay, so if I divide it by 8, 1024 divided by 8 is 128. Okay, 8 I know is 2 and a 2 and a 2. Done, done, done. Okay, now 128. 128, if I divide it by 4, okay, I can go 4 and 32. 4 is a 2 and a 2. That's done, that's done. 32, I'm going to run out of room. I'm going to bring 32 over here. 32 is a 8 and a 4, and I know a 8 is a 2 and a 2 and a 2. That's done, and a 4 is a, so 1024 is just a ton of 2's. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Alright, so it's the 5th root. 1024, you should swap it out for 2 to the 10. Okay, so the index is 5, so they're going to leave if you got 5 or more. And I got 10. So how many groups of 5 are there in 10? And your answer is 2. So 2 groups of 2 are leaving, which is 4. Next. Okay, this one, you got the square root of 12 times the 5th root of 12 cubed. So let's morph it. Morph it to exponential form. So this would be 12 to the 1/2 times 12 to the 3/5. Okay, now when you're timesing, you add the exponents. So it should be 12 to the 1/2 add 3/5. And the problem is you cannot add halves and fifths. You can't add fractions unless they're like terms. They got to be like denominators. So halves and fifths, I'm going to change them both to tenths. Okay, now how many tenths is 1/2? 1/2 is the same as 5/10. And 3/5 is the same as 6/10. Yep, that's right. Okay, now that they're both in tenths, now you add 5/10 and 6/10. When you add fractions, you only add the numerators. So it is going to be 12 to the 11/10. There we go. Now, let's morph it back to a radical form. So if you morph this to a radical, it's going to be 12 radical, 10 is the index, and 11 is the exponent. So items can leave if you've got a group of 10 or more, and we have 11 12s. So how many 10s is in 11? So that means one of these 12s will leave, one group of 10, and one will stay in. So your answer is this: 112 is on the outside, 10th root, 112 on the inside. That's the radical version. If you need the exponential version, it's going to be 12 times, this is just a 1, 12 to the 1/10th. That is an awesome problem. Okay, u to the 1/3 to the 4/5. If you have two levels of exponents, you times. So it's u to the 1/3 times 4/5. And times is pretty easy. All you do is times your tops and times your bottoms. So it's u to the 4/15. If you have to morph that to a log, or to a radical, it is u here, 15 is here, and 4 is here. So the 15 means u's can leave if they're grouped up 15 or more. And you only got 4. So you're done. They stay put. Okay, the next one, q to the 3/5 divide q to the 2/5. That is q to the 3/5 subtract 2/5. So division, you subtract the exponents. So 3/5 and 2/5, that's nice because they are like terms. So you just subtract the numerators. That's q to the 1/5. And if you have to morph that to a radical, that's going to be q. 5 is your index, 1 is your exponent. You can leave if you got 5 or more. You don't, so that's it. Okay, now logs. Logs and exponents are inverse of each other. So the first equation you need to solve, it's an equation, you got to solve for b. b equals what? Move number 1, I'm going to combine these two logs. I am adding two logs that are both in base 10, and adding is related to times. So I'm going to shrink these two logs into one, and it's going to be log in base 10 of b plus 3 times b. And on the other side I got log in base 10 of 4. So I'm going to times this. It's going to be log in base 10 of b squared plus 3b. I just distribute the b. So I take the b and times it to both of them. Then on the left I got log in 10 of 4. Okay, now I can solve the equation because it is equals log 10 does equal log 10. So if log 10 is equal to log 10, that must mean that my b squared plus 3b has to equal 4. And this is not too bad. This is a quadratic equation. So let's bring the 4 over. So let's minus 4 minus 4. So I got b squared plus 3b minus 4 equals 0. And factor it. Let's change this to a times problem. It looks like it's easy to factor because it starts with the 1. So how they times to get b squared is just b squared, or b times b. And now you're looking for something that will times and give you a minus 4, but adds and gives you 3. So what will times and give a minus 4, but add and give 3? And it's just going to be a 4 and a 1. One of them needs to be negative, because it's got to times and give a negative, but it's got to add and give a positive 3, so there we go. So it is going to be a plus 4 and a minus 1. Now if you factor that, now you can find the zeros. And what will make this a 0? B has to equal a minus 4 or a plus 1. So b equals 4 or 1. That is it. That's your answer. Okay. The next one, combine these two logs using division. So it's going to be log in base 4 of x squared minus 4 divided by x plus 2 equals log in base 4 of 1. Okay, now this is equal to this, so that must mean x squared minus 4 divided by x plus 2 is equal to 1. So now let's solve for x. Let's get x by itself. Let's get rid of this bottom. Instead of divide by x plus 2, let's times by x plus 2. Let's times by x plus 2. So divide by x plus 2 times by x plus 2, that undoes. You get x squared minus 4. On the right side, x plus 2 times 1 is just x plus 2. Okay, now let's get everything on the same side. Let's move this over and let's move this over. So let's minus 2 minus x minus 2. X squared does not have anything to play with, so you got x squared. The minus x does not have anything to play with, so you got minus x. And these play together. Minus 4 and minus 2 is minus 6. And then on the right you got 0. Same thing, let's factor it. It starts with the 1, so it's going to be easy, hopefully. It's going to be x and x. What times and gives a minus 6, but adds and gives a minus 1. 3 and 2. 3 is negative, so minus 3 plus 2. So what will make this group a 0? X has to equal 3. What will make this group a 0? X has got to be a minus 2. So those are the answers. Okay, next box. Okay, more logs. Now, log in base 10 of u is equal to 3 halves log in base 10 of 4. So you gotta solve now for u. What the heck is u? Move number 1, if you look at it, this needs to be taken as an exponent. So if you're ever timesing a log by some number, you need to take it, move it to the exponent. So if you put that as the exponent, it's going to look like log in base 10 of 4 to the 3 halves. Okay, now we just did some of this. Let's look at what the heck 4 to the 3 halves is. Morph it to a radical. So if you go 4, 2 is going to go there, 3 is going to go there. So they're going to leave in groups of 2. So 4 is a group of 2. But, so you're going to swap the 4 out for 2 squared. But you have 3 of the 4s. So you really got 3 of them. So you have 6 of them. So if they leave in groups of 2, how many 2's make it out? And that should be, they should all come out. 3 groups of 2 come out. And 2 cubed is the same thing as 8. So this 4 to the 3 halves is just a really fancy way of writing 8. Okay, now we got on the left we got log in base 10 of u. Oh, this one's actually, you're done. So if you got that is equal to that, that means this equals this. So u is 8. Okay, the last one. 5 to the a is 120. You got to solve for a. So let's undo this exponent. And how you undo an exponent is a log. So you're going to go log in base 5 of 120, and that will give you a. So just type this in on your calculator. Log in base 5 of 120, and that's probably a decimal. Log in base 5 of 120 A is equal to 2.97463 blah blah blah. Okay. The bottom two, express each log in terms of a common log. Okay, the common log is base 10, and then then approximate its value to a decimal. Okay, so if you just type this in on your calculator right now, log in base 8 of 32. Let's do that. Log. Whoa, 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 whoa. Log in base 8 of 32 is 1.666 forever. Okay, but now this is base 8. If you need to express it in terms of base 10, it's going to be a fraction. It's going to be log in base 10 on top, log in base 10 on the bottom, and on the top goes 32, and on the bottom goes the old base. That is it right there. That's your answer. If you type that in on your calculator and press enter, it will give you 1.6, gives you the exact same answer because it's the same thing. One of them is in terms of base 8, which is what they gave you, but this, if you change it to base 10, it's going to become a fraction, but the answer on the calculator is the same. So let's change this base 5 into base 10. First of all, let's do it on the calculator. Log in base 5 of 12 is 1.54 blah 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 blah. Okay, now to change it to a base 10, you gotta go log in base 10 of the 12 divided by log in base 10 of the old base of 5. So there you go. Punch that on the calculator, it is 1.54 blah blah blah. Okay, last three. Solve for x. Okay, this is going to be just like this one right here. So if you're going to solve for a variable and it's in exponent, the only way to get it out of there is a log. So it's going to be log in base 4 of 27, and that's equal to 2x. Okay, now this, on the calculator, you can change this to a decimal. Log base 4 of 27. So, log in base 4 of 27. And let's probably go like 3 decimal spots or something. So it's going to be 2.38. What did I say, 3 decimals? Yeah, that's good enough. 2 decimals is close enough. 2.38 equals 2x. Now just undo the 2. So divide by 2, divide by 2, x. If you divide that by 2, final answer 1.19 if you're going to 2 decimals. Okay, the middle one, if you got to solve for w and it's in an exponent, the only way you can undo it is with a log. So you got to do log in base 5 of 17, and that is equal to the exponent, w plus 3. Change this to a number. You got to do it on the calculator. So, log in base 5 of 17, that is 1.76 is equal to w plus 3. So now undo the plus 3, minus 3, minus 3. W equals a minus 1.24. And the last one is the same. It's even the same base. Log in base 5 of 72 equals x. So now it's quadratic. Equals x squared minus 3. So that's going to be a little different. Change this to a decimal. Log in base 5 of 72 Alright, that's 2.66 equals x squared minus 3. So let's undo the minus 3, let's plus 3 plus 3. And you have got 5.66 equals x squared. Now you gotta undo the square. Square root. But you gotta give me both roots. You gotta give me the positive and the negative. So let's go square root of that. And your answer, x is gonna be a plus or minus 2.38. That's it.